this is 5.2 ratios. And what you're going to want to do on this first slide is just copy everything down that's in black here. I found this on the internet and thought it was a really good way to explain what a ratio is. I liked the pictures that they used, and I liked the definitions and things they use, so I just copied it on here. So a ratio compares two values. A ratio says how much of one thing there is compared to another thing. So in this example, there are 3 blue squares in 1 yellow square. So you could write that 3:1. Use the colon sign between the 3 and the 1. And you would read that 3 to 1. 3 blue squares to 1 yellow square. You could also write ratios a couple different ways. You could use the colon like they did, or you could actually use the word 2. You could say 3 to 1. Or you could write it like a fraction, 3/1. And we're going to use kind of a little bit of all of these. So it's important to know that all 3 of those ways are just fine ways to talk about ratios. Okay, so just to wrap our heads around this a little bit, let's talk about some ratios in real life. Where do we see ratios come up in real life? First thing I thought of was lottery tickets. I don't play a lot of lottery tickets because they're a bad idea, because most of the time you lose. But a lot of times, well, all the times, on lottery tickets, they'll tell you what your odds of winning are. Okay, so they might say like your odds of winning on a scratch off ticket are 1 to 100. Okay, that means that you have 1 chance of winning and you have 100 chances to lose. And that's why the lottery is a bad idea, because your chances of winning are a lot smaller than your chances of losing. That's how they make money from you. So odds are an example of ratios in real life. A lot of times you will see like student to teacher ratios. Like if you start looking at colleges, they'll advertise like, hey, you should come here because we have a very small student to teacher ratio. So it might say like we have a 20 to 1 student to teacher ratio. That means for every 20 students, there is 1 teacher. Okay, in most of my geometry classes, the classes that you guys are in, it's about 33 to 1. Okay, there's 1 of me, and there are 33 of you. All right, and then another one that a lot of you guys are probably really familiar with are like win-loss records. So say like the basketball team or the football team has a record of I don't know, say they're good. Say they're 14 and 2. Okay. Really we would want to write that 14 to 2 if we want it to really look like a ratio, but that means that you have won 14 times and you have lost 2 times. So win-loss records are really just ratios. All right, so one more thing to talk about before we dive into some examples. There's something called an extended ratio, and that's where you have more than 2 parts. So for example, the extended ratio of angles in a triangle is 4 to 5 to 9. So you see there's 3 parts there instead of just 2. And we're supposed to find the measure of all 3 angles. Okay, so here's how you would do a problem like this. You know that the angles in a triangle are going to add to 180 degrees. All right, and we're going to use this ratio here to solve the problem. Okay, so our angles obviously aren't 4, 5, and 9. That's not going to work. 4 plus 5 plus 9 is definitely not equal to 180. So it's not just 4, 5, and 9. What it is, though, is it's 4 times something plus 5 times something plus 9 times something is going to be equal to 180. Okay, we have to figure out what that something is. So we would do 4x plus 5x plus 9x altogether is 18x is equal to 180. And then divide by 18, divide by 18, and that's going to give us 10. Okay, so we're not quite done yet. What we need to do now is take this 10 and substitute it in for each of our x's. Okay, so angle 1 is going to be equal to 4 times 10, which is 40 degrees. Angle 2 is going to be 5 times 10, which is 50 degrees. And then angle 3 is going to be 9 times 10, which is 90 degrees. And we can always double check our work here. Add those together. 40 plus 50 is 90. 90 plus 90 is 180 degrees. Okay. Example 2. The ratio of a set of complementary angles is 25 to 5. Find the measure of the angles. So this is not an extended ratio. This is just a regular ratio. And we need to recall that complementary angles are two angles that add to 90 degrees. Okay, so we're going to do it kind of the same way. We're going to say 25x plus 5x is equal to 90. And then add those together. We get 30x equals 90. Divide by 30. And x is equal to 3. Okay, so then what we need to do is we need to take that 3, substitute it back in to each of our x's. So angle 1 is going to be equal to 25. I really should be saying measure of angle 1. 25 times 3, which is 75 degrees. And then measure of angle 2 is going to be 5 times 3, which is 15 degrees. And again, we can double check, add them up, make sure that equals 90 degrees, which it does. Okay, so the two angles are 75 degrees and 15 degrees. I'm going to slide back here. We're going to add m's to each of these. You guys can do that in your notes as well. If we're being correct, we should say measure of angle 1. We're talking about degrees. On to example 3. This one says the perimeter of a quadrilateral is 60 inches. The ratio of its sides is 3 to 7 to 9 to 11. So 4 different numbers here because we have a quadrilateral which has 4 sides. And we are supposed to find the length of each side. So for this one, I'm just going to draw a little picture. You wouldn't have to, but I think it might make it a little bit easier to understand what's going on here. I really don't know what this quadrilateral looks like, but I know that it has 4 sides. And one of the sides is going to be 3 times something, and another side is going to be 7 times something, and another side is going to be 9 times something, and the last side is going to be 11 times something. Now, that's not to scale at all. We have, a side that's 3x and a side that's 9x, and they look pretty similar, but they really shouldn't be, but that's fine. Just helps us kind of figure out what we're looking at here. The other piece of information that we have is the perimeter is 60 inches. That means that the length all the way around is 60 inches. So what that means is that 3x plus 7x plus 9x plus 11x all together is 60 inches. Okay, so we can solve it from there. 3 plus 7 is 10, plus 9 is 19, plus another 11 is 30. So we have 30x equals 60. Divide by 30, divide by 30, and x is equal to 2. Okay, now we can go substitute that back in. So basically we're multiplying each of our sides by 2. 3 times 2 is 6, 7 times 2 is 14, 9 times 2 is 18, and 11 times 2 is 22. And we could add those together and make sure that we end up with 60. I believe we do. 6 and 14 is 20, 22 and 18 is 40. So yes, 20 and 40 is 60. So that would be correct. All right, that's it for this one. Definitely make sure that you practice hard on this one because there's quite a few new things going on here.